Welcome to our new video. So today we will solve the problem longest repeating character placement. You are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Let's take an example. So what the question is saying, suppose you have a string AB and we have k equals to 2. So we can do at most 2 replacements to make our longest substring containing the same letters. Means, suppose this is a substring, if this is a string, if we replace B and B with A and A, because at most we can replace 2 characters, so it will become A, or we can replace 2A with B, so it will become B, and we can replace with any character of the English alphabets, uppercase character, not necessarily A or B only. So let's take a example and let's do the dry run. This is the pencil I will take. Suppose this is the example A and K is 2. So how will we do? Let's take the brute force approach first. So we will create substrings using 2 for loops. So let's create one substring A, another substring starting from A, another substring starting from A. Like this way we will create the substrings. Okay, so let's start. Also we have to remember that we can replace only at most 2 characters. So at most 2 characters, so we have to keep in mind this. Now what we have to do, suppose we have taken this, so what max length becomes, it becomes 1. Suppose we taken this, what is the max length of longest substring with all the letters same? So in this A and B both are equal, so if we'll calculate from which alphabet we have to replace, for which alphabet we want to replace, we'll have a tie. Suppose what we have to replace, we will say change and total length of substring minus frequency, max frequency. We will store our frequency in an hash of 0 to 25. I will do original SK value of A is 65. We will do it minus A and we will store it in this hash, and we'll do plus plus. Suppose A is having 1 and similarly B is having 1, so both frequencies 1. So length of the substring is 2 minus max frequency 1 equals to 1. So only we need to change only one character. Suppose like this character we are changing with A, so max length becomes 2. Okay, now suppose here we are taking this substring and it is within the one character we could easily replace, so we replaced. Now in this 3 character substring we have maximum frequency of B. I will show you. frequency of B is 2. This is B, this is A, suppose this is C, etc. Now here max frequency is length is 3 minus max frequency is 2. That means we need to change one element, which is this. We can easily change with it B and our max become 3. Now suppose this substring. Now here what is the maximum frequency of B? 2. So length is 4 minus 2 equals to 2. We need to do two changes, two replacements. We can do this replacement and this replacement with B, because it is within the limits. So now our max length becomes 4. Now our substring becomes this. Now here you see how many characters are there. Max frequency is 2, characters are 5. We need to do 3 changes. This is not possible, so we will break the loop. Now we will start from here. Similarly, do this, do this, do this, do this. In this also we will get only 4, and in this also we will get only 4. So answer will be 4 only. So this is the brute force approach. Let's try to code it and understand how we'll code it. So first of all, we make a max length equals to 0. We will start a for loop from I equals to 0 till I equals less than s dot size. Then we'll make a hash array of 26 size, initialize it with 0, and we will start a for loop from that index till s minus size. This is the two for loops we are generating array. These two for loops we are using to generate two substrings, number of substrings. So if suppose now we got, and we will put in the hash, we will put this in the hash as minus a, because capital uppercase will increase in the hash table. And if our, we'll take a max frequency also. Within the substring, int max frequency equals to 0. If so, we will calculate max frequency equals to max of max frequency, comma, hash of j. It is a substring. We got the max frequency of that substring, which I had shown you. And suppose here in this substring, B has the maximum frequency. So now what's we have to calculate is int change equals to replacement. Total replacement means length, which is how to calculate length, j minus r I plus 1. This is the length of the string minus max frequency. Okay. Now if change is less than equal to k, then we can update our max length by max of max length comma j minus I plus 1. Otherwise we'll break the for loop. Simply break the for loop because it was of no use. Now we'll simply return. We'll submit. Index out of bound. See, it is running, but it will not be submitted because of time complexity of big of n square, and time constraints are this. See, time complexity. So what to do now? We have to see optimal solution. Now let's see the better optimal approach, better solution of this. So what could be the solution? Like in the previous video we saw, we are applying two pointer and so we will use sliding window technique. Let's take an example so that we can do a dry run how it is working. Suppose this is an example of this question. We will take example A B B C C. Let's take this example. Let's keep one left pointer here, right pointer here. Let's create a map here. Suppose this is the map, and we take the max length variable and also max frequency. If we calculate max frequency, we can calculate replacements, which will be window size minus max frequency. Okay, let's start. So first of all, we will put A in the map, then R moves, max length becomes 1, then 2, and max frequency also becomes 2. R is here, A updates to 2 in the map. Replacement is, first of all, replacement was 1 minus max frequency, which was 0. It is less than equal to k, and k is, let's suppose, 2. K equals to 2. And now window size of 2, 2 minus max frequency also, 2 minus 2 equals to 0. 2 minus 2 is equals to 0. Okay, Now we are seeing this. We will move the R pointer, update the map with b, 1, max length becomes 3, and window minus max frequency becomes, I will use eraser. So replacement becomes, now max frequency becomes 2 only, because it will not update through 1, and max length is 3. Why? Because the replacements are window size is 3 minus max frequency is 2, 1, which is less than equal to k, which is wait a minute, which is less than equal to k. Okay, again it can be moved. Now we will see again the replacements. Max frequency 2, window size is 4, it becomes 4 minus 2 equals to 2, and max length becomes 4. Now when r moves to c goes to map, and now we see max frequency is 2 only, and replacements are 5 minus 2, which is 3, which is greater than k. Now max length will not update, we have to update L. Now we have to trim the window size, because now the replacement's character becomes more than k. So move the left pointer now towards here. So frequency of A decreases to 1, and max frequency also decreases to 1. Now again check. Max frequency is 1, because max frequency is still 2. Why? Because see, in the map b is having the value 2, so max frequency will remain 2 only. We can check this by using a for loop. Over map or hash table. So we can calculate the frequency in each step when we trimming from left side. Okay, max frequency is still 2, so replacements window size is also, now see the window size is now 4 minus 2 equals to 2. Okay. Actually window size is max frequency is 2, and okay, this is here 4 minus 2, 2. Now we can update the max length, but it will be remain 4 only. So now increase the right pointer, not left. Increase the right pointer. Now increase the C frequency. Now max frequency is 2 only. Replacements is 5 minus 2 equals to 3. Now again we have to trim from the left side. Move the left pointer. When it reaches to B, window size is 4, max frequency is 2. We will calculate again. Now max length is again 2 only. Now max length is again 4 only. So max length will remain 4 only, and now our right pointer will move ahead. So max length answer is 4. So this is the working we have to do now. So how we'll do now, see the code. Let's make 2 pointers, left and right. Make a max length variable. Also make max frequency. Now start the loop. First of all, right index we will move, right pointer. First of all, put in the map. We'll create hash also, hash table of 26 size. We will use array like this. SK value is 90, capital values are there, so SK value is this. To convert into 0, base indexing for A. To put capital A on 0 index, we have to do this 65 minus whatever we will get the SK value, we'll subtract it with, suppose we got B, we'll subtract it with 65 with A, which is equal to 66 minus 65 equals to 1. So it will be put on the 1 index. Now put in the hash. What we have to put in the hash? S of j minus A plus plus. We have to give the frequency also, that's why. Now check if calculate the max line. Actually max line is equal to max line comma hash of ji sj sr. Actually, where is j come from? sr minus a. So how this is working? Suppose you got simply a for loop for calculating max. We use a for loop for calculating max in an array. So this is how it is calculating. Arrays of hash, which is having the maximum frequency, will stored in the max len. Now we will check changes or replacements. Replacement characters will find by r minus length of sub window. What is the length of the window? R minus L plus 1 minus max length. This is the size of window. Now we'll check if the window size is greater than k. So what we'll have to do, we'll have to move the left pointer, and also we'll decrease the hash value of that left pointer by 1. And actually it will be, because we have shifted the displaced the indexes of A as according to SK. According to SK it was 65, but we have shifted to 0, so that our hash map size is 26, not 255. Now we have decreased this part. Now we have to move to next part, which is decreasing the map frequency, changing the map frequency also by using for loop for I in hash actually for int I less than equals to 26 I plus plus, we have to calculate max len equals to max of max len comma hash of I. Okay, now we have to increase the left pointer. Okay, now check if replacement are less than equal to k, then we can update the max len. Obviously it was max frequency, we are taking max len by mistake. Max frequency, it was my mistake. Max len equals to max comma r minus L plus 1 comma what it should be window size and max len. Okay, and we have to move r plus plus always, right pointer always. Now we will return the max len. Let's check. Wrong answer. Why? Our output is 7. Output should be 4. Now let me check. Plus plus and also hash of I equals to 0. What's the problem? I'm checking. Wait a minute. Max len, no. Max frequency. It should be max frequency. My mistake. My mistake over here also. Now check. Now what a mistake. LR 0 plus plus. Okay. Everywhere I have written max len. It should be max frequency. Now you will see it is working. Now runtime error. Why? Let's check. So there are some more bugs. Let's fix them. First of all, update the max frequency here to 0 first. Then we'll find the max frequency, new max frequency, and also in replace we would apply the logic of this to here, because it's a while loop. It will be updated. L value is updated every time, so it should recalculate itself again and again. And also max frequency of changing. Now it's right. Now where is replace? I'm not okay. Now it should be good. Hope you understood. Now let's move to our optimal solution, which is also covered in the previous video, but let's see again what is the intuition. Now why we are first of all, see the time complexity of this. See, time complexity is big of n here, big of n here, and similarly this while loop and overall is big of n. If L goes to last index, it will go in chunks, like according to while loop it can go to 2, then 4, then last. It can go accordingly, but overall it is big of n. It will not be multiplied, it will be added to the big of n. Now this for loop will be multiplied big of 26 every time. Okay, so this is the time complexity. What I will add here big of n plus n into 26. Into 26 is outside. So this is the overall time complexity. So we can reduce this to big of n only. How? And space complexity is big of 26. 26 is space complexity. This is TC. Now in optimal we will do this. In optimal we will do this big of n. How? Now see here. We are updating max frequency again and again. We do not require this. Why? Let's see through dry run. Suppose L was here and R was here, so max frequency was 2. Here max frequency is 2 only. Now let's take another example where I can show you the working. Let's do the run again. Let's start from here. We will take example A, B, B, C, C. Now let's see. L is here, R is here. We will update the max line. Max line is initially 0. Now we will put inside the map. What we will put? A, 1. Now we will move again. Also max frequency. We have to see the max frequency rule. Max frequency is initially 0, then it was 1. After first index it becomes, when R increases it becomes 2 when maps update. Now here max frequency is 3. This is also 3. This is also 3. Now see here, maps got 1, max frequency is 3 only, and max length is also, because it is, see, replacements changes, window size 4 minus 3 equals to 1, which is less than equal to k, so it upgrades to 4. Similarly, max frequency is again 3 only, so 5 minus 3 equals to 2, which is less than equal to k. Let's take one more B actually. No, let's not. Windows max line increases to 5. Now R updates again, R increases again. Now it got seen in the map. Now see, the window size is 6 minus max frequency is 3 only, which is 3. Now it will check, it will update the L. When it updates the L, we decreases this in the map. Now in the previous solution we were updating the max frequency, but see, max frequency, if we will decrease, it will not impact the solution. It is still greater than k. 4 is still greater than k. And for increasing max length will increase from 5 to 6 if the change is less than, number of replacement is less than k. But here if we are decreasing max frequency, it is decreasing, so it is not needed that we decrease the max frequency, because it is deviating away from the solution, optimal answer, optimal max length solution. So if we will, actually we need what? We need 6 minus 4. That's why it will be able to come 2, and when it will be 2, then window size is 3, so max length update, window size is 6, then max length will become 6. But when we are taking 4, or when we are taking 3, or reducing it to 2, max length, if we are reducing it to 2 by updating, by doing for loop, it is becoming 6 minus 2 equals 4, which is greater than k. We will not be able to find answer with this anyhow. And similarly, so max frequency decrement never leads to a solution, so it is of no use to decrease max frequency. So this is how we remove the 26 times for loop. Now we have to also remove the while loop, which you have saw in previous video also. Because the window size is this, so we do not need to traverse the L till it becomes less than equal to k. What we can do, we can keep increment R pointer and only increment L once. Suppose I will do the run. L is here, R is here. We will decrement it by 1, and we will increment it by 1. And now see the window size. What is the window size? It is 5. It is not possible, so we will just increase the right pointer. Now window size is 6. Now 6 minus, again it will not be possible because frequency is 2, maximum frequency is 3, which is greater than k. So again we will update the L by 1. Now see, when window size was this, again R increases, so it will not lead to a solution. That's why we do not need a while loop. We can just use N1 if incremented by 1 every time, and we will reach to the solution 5 only. Anyhow we will reach the solution 5 only. We cannot reach the solution to 6. So this is how we will remove the while loop. Now let's code this solution. We just have to remove this if, this while loop, and just remove this for loop. Never update frequency, max frequency. Now run this. Submit. And boom, 100% runtime. So now the time complexity reduces to O of n. Thank you and have a nice day.